Hi everyone, welcome back to our channel. Today we are going to solve problem number 48. This is validate or prove the reciprocity theorem. So in order to prove the reciprocity theorem, we should look that only one source should be there in the network. You can see here only one source is there. Okay. Now we need to find out, and load resistor given is nothing but the 2 ohm. So in this branch we need to find out the current. So this is the excitation, and this current is nothing but the response. We have to prove that excitation to the response remains same. Excitation to the response is same. Okay. So now in order to prove it, okay, let's try to mark this node as some Vx. Okay. And if the node is Vx, let us assume that current flows in this branch as I1, the current in this branch as I2, the current in this branch is already marked IL dash. Okay. So now let's try to apply nodal analysis, that is Kirchhoff's current law at node Vx. Okay, so at the node Vx we are going to apply. So what are the entering currents? You can see here there is no entering currents, all are leaving currents, which is nothing but I1 plus I2 plus IL dash. 0 is equal to, how to write down this current which is flowing in this branch? So the voltage at this point is plus Vx. So this is Vx, and current is leaving, or the leaving terminal minus Vx minus 10 divided by 2. Next, how to write down the current in this branch? Vx minus 0 by 3. So Vx minus 0 divided by 3, plus how to write down this current IL dash which is flowing in this branch. We want this current actually. So Vx minus 0 divided by, you can see here this 1 and 2 are now connected in series. 1 plus 2 is equal to 3. So now this will come like this, is nothing but minus 5 plus 5 is equal to, take Vx as a common term. So then we are going to get Vx of 1 by 2 plus 1 by 3 plus 1 by 3. Just use your calculator and determine the value of Vx. Therefore, you are going to get the voltage as 4.310 volts. Okay. So now we require IL dash. Okay. So how to write down this IL dash? Already we written IL dash is equal to, so what is the current in this branch? I mean current in 2 ohm and current in 1 ohm, both are same. There's nothing but IL dash is equal to Vx minus 0 divided by 3. So what is the value of Vx? 4.310 by 3. When you do with your calculator, you'll be getting it as 1.436 amperes. So excitation means input voltage. What is the excitation voltage? 10 volts divided by current of 1.436. When you do with your calculator, then you are going to get the resistance as 7 ohm. So this is one part. Okay, with one resistor connected we have done it. Now let us try to interchange the positions of voltage source and branch currents, and let's try to determine. Okay, I'm going to redraw the network. See here, this voltage source I'm going to short circuit, and I'm drawing a 2 ohm resistor, and next one is 3 ohm, and next one is 1 ohm and 2 ohm. Okay, and we are inserting the voltage of how much? 10 volts. So here we are inserting that voltage 10 volts. This is 3 ohm, this is 2 ohm. So now we are applying the voltage. In this branch, we are applying the voltage and we are finding the current IL double dash. Okay, and we should get the same parameters, then our theorem is validated. So now in order to find it, similarly, I am marking this node voltage all once again as Vx. Okay, so therefore when you apply it, let us assume the current in this branch is I1, the current in this branch is I2, the current in this branch is I3. Okay, so now in order to obtain the value of Vx, apply nodal analysis, which is nothing but Kirchhoff's current law at node Vx. Okay, when you apply, you can see here there is no entering current, all are leaving currents. 0 is equal to I1 plus I2 plus I3. So 0 is equal to, how to write down this branch current? I want to write down this branch current. Okay, so this I can write down plus Vx, and current is leaving. What is the leaving polarity of the voltage? Minus 10 divided by R. R is nothing but sum of these two. 1 plus 2 is 3. Plus, how to write down the current I2 in this branch? So the voltage at this point is plus Vx. Vx minus 0 divided by R. R is how much? 3. I2, how to write down this branch current? So this is Vx minus 0 divided by 2. So when you do it, this is minus 10 by 3. Here you are going to get plus 10 by 3 and take Vx as an common term. Okay. So when you take this Vx as an common term, then we are going to get it as 1 by 3 plus 1 by 3 plus 1 by 2. So just use your calculator, then we will be getting the value of Vx. Okay. So the value of Vx, you are going to get it as 2.85 volts. Okay. So this is the value of Vx. But actually what we require the current in this branch. Okay. So current, which is nothing but I3 we require. Okay. So this is a current. This I3 is nothing but we are calling it as IL double dash. IL double dash is nothing but I3, where I3 value is how much? So the current in this branch. Okay. So the current in this branch is how much? Vx minus 0 divided by 2. So 2.85 by 2, you're going to get 1.43 amperes. So you see here the excitation to the response. Here also excitation is how much we applied? 10 volts. 10 volts divided by current is how much? 1.43. Then also you are going to get same value. Okay, so when you give the voltage at this side and you find the current, the amount of resistance offered by the T network is same whether you change the voltage sources or the current in the branch. So the total network, I mean this T network, is offering a resistance of 7 ohm. If you interchange the positions of voltage set, this branch, if you interchange also, there's nothing change, the resistance remains same. This is called excitation to the response remains same. Hope you are able to understand the video. If you feel my content is useful to you, please like the video, and those who are studying the same subject, share to your friends. And if you have any doubts in my explanation, let me know in the comment section. I can answer your doubt. And if you're watching the channel for the first time, subscribe to my channel with the name KV Tulsi Ram. So kindly encourage these type of channels for the development of society and faculty. Thank you for watching. So if you are unable to understand the problem, listen 2 times and see that just by watching video nothing you get. Just write down the given question, you follow the procedure, how I done it, and see that you get the same answers. Okay. So thank you for your time. We'll meet in the next video.